Alright, welcome back everyone. And so in this video, in the previous video, we looked at how to how to use OrCAD PCB Editor, and we did a layout or routing of our complete design, and we added the traces. When you place the components, we added the traces, we added mounting holes, we added text information onto our board. Our board is finished. We have some supplementary information, dimensioning information, a drill legend that showing me all the hole sizes and hole types and how many of each there are. You know, my schematic, or to be more precise, my mechanical, this is really a mechanical drawing, is complete. Right? So now comes the final part of this second phase, which is what is the ultimate asset that we need to generate, and that is the so-called Gerber files. Okay, let me just give you a quick overview of what we're going to do. And this was from a previous video. Let me go ahead and start a new image. Nope, I did not want that to be that. Let's go back to white for background. Okay. So, you know, the PCB industry, okay, the PCB manufacturing industry, usually prefers what are called Gerber files, okay, and we loosely call them Gerbers. It's just a standard format. I think that's what it used to be called. A company that defined the original format, and they called it Gerbers. Okay, but Gerbers is nothing but a file which consists of a vector-based drawing, very loosely speaking. All right, you know, the drawing has no information about whether, you know, a layer contains copper, or it contains components, or it contains, you know, reference designators in each layer, or mounting holes. You know, it's just graphic, nothing, just simply graphic elements. The Gerber files have no knowledge, particular knowledge of the electrical connectivity from a functional standpoint of your design in a manner, for example, the way that the netlist file does. Right? It's just an art file, which is also why in OrCAD, you know, the Gerbers are also called artwork files, because in the end that's all it is. Okay, when we're working with Gerber formats, there's usually two predominant formats. Before, in the past, there used to be Gerber what's called RS274D. Nope, no, it's 274D, right? And so, you know, every layer from your PCB board needed to be of this format, and in addition to however many layers you generated, you also need to provide what's called an NC drill file containing the location of the holes and their sizes. And also you needed to include something called an aperture list. Okay, so this could be, you know, top layer, bottom layer, copper layer, silkscreen layers, you know, solder mask layers, and a board outline, for example. So you have several files, one for each layer of this format. In addition, you would have an NC drill file. In addition, you would provide an aperture list. But then the industry moved on to what's called RS274X format, and with this we have the same situation. We generate all these layers in separate files, okay, but then we also need to provide the NC drill file separately, and it just so happens that the aperture, this file, is actually embedded inside of this RS274 Gerber generated artwork file. So we do not need to generate a separate. I will show you how to generate this file anyways, but because we will be using 274X, it's really not needed. So this is just to make the video complete. Okay, let's go ahead now talk about the formation of layers. So basically, you have a board with many layers. Okay, so for example, on the top layer you have a copper layer. Okay, so let's say well, we pick green there. Let's see. Okay, so we have green, say, for the top layer. So I have a layer here for green, you know, and you have all your traces, blah blah blah. And in fact, let's add another layer, because this is actually a good example of what is happening. So we add another layer, and then maybe we have the bottom layer, you know, and you have traces going in the opposite direction, whatnot. Okay, then we have another layer. Let's say make it that, and you have the the solder mask, which is on top of this layer to protect the whole board. Then you have another layer consisting of the reference designators. Right, so you have U1, U2, maybe you have little graphics that show you how to U3, blah blah blah, etc., etc. Anyways, each of these layers will generate a file, a Gerber file separately, only containing that information. So what we're going to do, I'm loosely illustrating the point here, is that we're going to use the color dialog to turn everything but a specific layer on. So for example, here I have the let me just here I have maybe say the bottom layer, right? So then I generate a file for this, and this file will be called the bottom copper layer. And this could be the bottom copper layer. And I generate a Gerber file, and OrCAD gives it an extension of art. Then I use the color dialog to turn everything about this layer off, and then I turn another layer on, just these components, and then I generate a Gerber file from this, and then I call this the top copper layer. Art. And then I turn all of the things, all the visible features of that layer off, and then I turn another layer on. So this could be the solder mask layer, right? And I generate a solder mask, a Gerber file. Then I turn everything off in the color dialog, and then I turn specific features on that are specific to the reference designators, and then I generate another one and call it the silkscreen for the top. Right, so each particular layer will have its own file, and the composition of all these layers is that we have the complete board specification. So you will need and to list the proper you will need a bottom top. You will need a file for the top copper layer. You will need, on top of the copper, we have the solder mask. So we need a top solder mask layer. Then on top we have the silkscreen, the white paint, all this, the legend, the reference designator. So we have top silkscreen layer. And then we repeat symmetrically. We need everything for the bottom. We need the bottom copper. We need bottom solder mask. We need bottom silkscreen. Okay. In addition to that, we need the locations of the holes, right? They're going to be drilled away. So this is a separate file called an NC drill file. Okay. And then again, if you're using RS, a Gerber file RS274D, then we also need another file called the Aperture List. But again, it's not needed if we're using 274X. Okay, so as a bare minimum, you take all these files after they have been generated and you stash them in a zip file, along with perhaps a README file inside of the zip or separately, that briefly describes what these files are. Okay, so for example, if you generate a Gerber file called top.art, well, that's not very descriptive. Say, that this is a copper, the Gerber file for the top copper layer, etc., etc. And if you have a layer just called bottom, corresponding to the bottom copper layer, then describe in the README file that this is the file for the bottom copper layer, etc., etc. And you provide your name and your address and contact information, put all of that in your README file, stash that into a zip file, and this is what you submit to the manufacturer for your production of the board. Okay, so that is basically generally at 30,000 feet what you need to do here in OrCAD Capture. And that's the topic of this video. So let's just go ahead and get started. So again, I said so we're going to generate the Gerber files. The first thing that I'm going to do, and again, just as I created a backup, let me make sure I go back and I make sure that this is saved. So Control S to save. Yes, I want to overwrite, and I'm going to make a backup of my current board file, and I'm going to call it final, because as far as I'm concerned, it's pretty much done. Okay, because I'm going to change the visibility of all this stuff, and I want to be able to put everything back the way it was, the way it is currently. Okay, there's no easy way to do that. So we're going to open the Color Dialog box, or actually, let me just go back. So the Gerber files are generated from the artwork control form, which is accessible via the artwork panel. So if I click on artwork here, I already have 2 layers here that will be generated into Gerbers once I do generate the artwork by clicking the Create Artwork button. Okay. Each layer has certain attributes that are visible elements, and so we have the bottom copper edge. I'll try to think of edge as synonymous with copper. Okay, so bottom copper, we have bottom pins if there are any pin features, and bottom bias. Okay, and that's really the only thing should be in any layer. If I go here for the top, I have top edge, top pins, and top bias. If you click on, since bottom is not very descriptive, just click on it once on the name, and let's call it copper bottom, and then let's click on this once, select it, and click on it again, and then copper top. Okay, so these are going to be my copper layers, and if you right click on the layer and say displays for visibility, notice that we can see only the the bottom layer, right? And since the pins go through both the top and the bottom layer, we're going to see pins and pads on the bottom layer, and we will also see them on the top layer. If I go into top layer here on my artwork control form, right click and display for visibility, notice that now I see only the top layer and what's going to comprise that. Alright, so we have 2 layers out of the several layers we got to generate here, right? And now we need to generate the solder mask and the silkscreen. Alright, so let's go ahead and do that. So we're going to add several of these folders comprising layers containing information that is specific for that layer. So let's go ahead and open the Color Dialog. I'm going to put it here so I can see. Alright, I'm going to turn everything off globally, and make all classes invisible, and apply. And I see nothing because nothing is visible. And I want to see now the let's see, the solder mask. So for that, we go on to board geometry. First of all, on the stack up solder mask, we want to engage only the top. So we're going to do the top solder mask here. Okay, then under board geometry, top solder mask. Package geometry, top solder mask. Let's hide the palette here. Top solder mask. Embedded geometry has nothing. Components is we want there's no solder mask layer, so that's okay there. No solder mask, no solder mask, no solder mask. So you just click apply, and this is a solder mask layer. Okay, so therefore I go here into my artwork control form. And again, that's for the top solder mask. So I'm gonna don't hit the add button here. Instead, select here a layer and click on add. Okay, and I will say solder mask top. Click OK, and now I have my solder mask. Okay, if I say display for visibility for the bottom top cover layer, and I go back to the solder mask and display for visibility, notice that only that information. If I expand, I see everything that I have decided, every visible component that I decided be part of this particular layer. So I have bias, pins, package geometry, solder mask top, and board geometry. Okay, so We continue, and we're going to repeat this. Now again, I'm going to go back into my color dialog. I'm going to turn everything off. Yes. Apply. And now we're going to repeat the same, but now we want solder mask bottom. So solder mask bottom there. Areas, let's see, board geometry, solder mask bottom. Package geometry, solder mask bottom. Manufacturing, there's nothing there, so that's all we need. Click apply, and now we have the bottom solder mask. So I go back to my artwork control form. I right click, add solder mask bottom. Okay, go back. Now we're going to do the silkscreen layers. So again, turn everything off. Yes. Apply. Right, and I go back to my stack up, and I want my silkscreen layer. So there's no silkscreen here. It would probably be under, yeah, board geometry has a silkscreen, so we'll do silkscreen top. Okay, package geometry, silkscreen top. Okay, components, silkscreen top, and I only want the component value and the reference designator. Okay, manufacturing, no silkscreen and no silkscreen in analysis, so apply, and that's my silkscreen from the top. So all of this will be the white paint on my circuit printing board. So everything that is white in my image here, that's going to be part of the silkscreen top. Okay, so we go back to the artwork control form, right click, add silkscreen top. Okay, I repeat, go back to my artwork control form, turn everything off. Yes, and now I want the silkscreen bottom, apply. Okay, so stack up, nothing there. Areas, nothing there. Board geometry, silkscreen bottom. Package geometry, silkscreen bottom. Components, silkscreen bottom, and again just component value and reference designator. Manufacturing, nothing there. Okay, apply. And only my name here on the top. Remember, I put my name in the bottom side on the board, so that's the only thing that's on the silkscreen bottom layer. So I go ahead, right click, add silkscreen bottom. Okay, what are we missing? Let's see what else. So we have, if we go back to our notes, so 1, 2, 3, 4, 5, 6, and that's everything we need. So you have everything minimum that we need for the generating the Gerbers. Okay, now I can add additional information for you know, maybe I can make a mechanical drawing. So how would I make a mechanical drawing? I turn everything off. Okay, and maybe for the stack up I can have just the pins. Okay, so I showed the pins for the top and bottom, top and bottom. I don't want the edge and nothing else, just the pins. If I apply, I can see the pins here for the top and bottom. Maybe for my package geometry I can do let's see, maybe we could do assembly top and bottom, and that shows me where the parts are going to be. Or we could take that off and we could go on to components, and I can show the silkscreen for top and bottom, reference designators top and bottom, and apply component value. And let's go back to package geometry assembly. I do want to see the top and bottom of the package geometry so that I can see that. That's odd though. Let me go back to package because the package, see, components, manufacturing, yeah, package geometry top and bottom. I want that there. Sorry, not that. Solder mask, silkscreen. That's where the paint is. That's what I wanted to see. There we go. Okay, so and then maybe the board outline. We need a board outline actually, and I forgot to do that in the other video. Let's go back. It means our board is actually not complete. Or let me see. I think that we can do a board outline. Package geometry outline. Apply. That's my board outline. Okay, so I can click OK, and then I can. This is now a composite. You know, this is not something I would send the manufacturer, but this is a composite for me, and I can go ahead and I can add it and call it add mechanical, right? And so I can actually print this particular layer out and maybe set my parts on the sheet so that I can make sure that my parts, they line up with the chosen footprints and whatnot. Although at this stage you should have that information already figured out. There's one more layer that I need to add, and that is the outline layer all by itself, because the manufacturer needs an outline layer. Usually the outline, there's two ways you can handle this. You can either draw an outline on this solder mask, on the silkscreen top layer along with your reference designators, or since there's already an outline in our design, we can go to the color dialog and we can turn everything off, apply, hide the palette, and just hit the outline button, click apply, and then here I can just add another layer and call it board outline. Okay, and we're done. So each one of these folders will generate an individual Gerber file. Okay, we're almost ready to do so. Let's dismiss the color dialog. Before we do, we need to go to general parameters and make sure that the device type is set to Gerber RS274X. Okay, the format for the integer format, the numerical format specified in the file, it's usually 2.4, and you will get a an error here, or a warning sort of. Just click OK and dismiss it. Okay, usually leading zeros need to be suppressed. And once again, where do you obtain this information? That you have to have RS274X, that you have to have 2.4, that you have leading zeros suppressed. This comes from the manufacturer. Once again, you need to go to the manufacturer's website that you have chosen to build your PCB, and usually they have a set of rules on what kind of files you need to submit and in what format they should be. Okay, and usually they will at very least specify the Gerber format, the numerical format, how many integer and decimal places, and whether you should have leading zeros suppressed or not. Okay. Next, while we are in this panel, I talk about Aperture List here, and I said that you don't need it if you have RS274X, which we don't. But if you were using RS274D and you needed to generate the Aperture List in older versions of OrCAD, the way to do that is that you click on the Apertures button. This will bring the Edit Aperture panel, and all you have to do is add cancel. Let's see. Usually there is a here. So click on the there's several aperture wheels. So we only click on the first wheel, click on Edit, and then click on Auto without rotation. Okay, and then the list will be automatically populated. Okay, and you click OK and click OK here, and then an aperture list will be already generated in the stashed into your Allegro folder, and I believe that that is the aperture text here. So if you double click on this file to view its contents, we have the aperture list in there, and that's what the aperture list contains. Okay, so that's generated there. Alright, let's go back to generating our Gerbers. There's one more thing we have to do before we generate some of these. Sometimes there are graphic elements that, even though they are visible, such as, and specifically to be precise, let's say the silkscreen layers, if I display for visibility, it turns out that many of these graphic elements actually have zero width defined. So we can see them here, but they will not, when you generate the Gerber will not have anything to see. You will not be able to see anything because the lines have zero width. Okay, to overcome that potential problem or gotcha, there is a field here that says undefined line width. Okay, and for each layer that has an undefined line width, I would go ahead and I would set this to at least maybe a value between 5 and 10, and I would set it to 7. Okay, copper top 7, Actually, let me take that back, because I only know that's a problem for the silkscreen layer. Let's just go for the silkscreen top and do 7, and then silkscreen bottom, and let's do 7, and let's leave the other ones as empty. Okay, and that's it. That we're ready to go here. So to generate the artwork, we just click on the create artwork, and basically that's all there is to it. You can view the log. Oh, there's no blog. Okay. And if we go onto our Allegro folder, let's see. There's no artwork generator. Why? Oh, because we need to select. We need to select what we want to generate. I want to select all these files to generate them, and therefore I click create artwork, and now it generates the artwork files. And then it says that it generated with some errors. It says photo plot outline rectangle not found, but that's okay because we added a Gerber file to include a rectangle outline, so we're good there. And then this has to do with the fact that we changed the format from 2.5 to 2.4 in the numerical formatting in the artwork control form. So you can ignore that because that is okay, and everything else should be good. Even though it says it created top and bottom layers with some warnings. And I think that has to do with the possibility that we may have some zero. I'm not exactly sure what the problem is there. So here on the silkscreen layer, it tells me that I have some text with zero width line format, but because we changed that, we're good. It's just letting us know. Okay, so I created the layers. Instead it has some warnings. I'm going to ignore those warnings for the time being. If you go into the my folder, I see that my Gerber files have been generated. If I organize my folder by type, I see all my art files are in here. And again, we don't send everything to the manufacturer. We only send them the board outline, copper top, copper bottom, silk screens, solder mask, and that's pretty much it. The NC drill, we got to generate the NC drill file. So let's do that next. To generate the NC drill file, we need to dismiss the artwork control form, and we go on to manufacturer, NC drill, okay, and we select NC drill here. Alright, and you could change the name to OrCAD tutorial. You could maybe just do underscore NC drill so that it stands out. Leave everything else the same. Alright, and then just basically click drill. Okay, and then we click close. We go back to our Allegro folder, and our NC drill file should be in here somewhere. And there it is, the NC drill file for layers 1 and 2. Okay, so now we would send all of these files except the mechanical one, and then the NC drill file, we would zip that up and send that to the manufacturer. Okay, so that completes the generation of the Gerber files. And again, you can generate more files depending on that contain all the information you want to see, and that's actually the power behind having so much control about what you can see and what you cannot see, etc., etc. One last thing before we finish here is the when you generate the Gerber files, you should not assume that they are in good shape. You should always investigate the Gerber files and view them in a Gerber viewer. Okay. Here I have a Gerber viewer called ViewMate from Pentalogics, and I'm not endorsing this particular one. I'm just saying that this is an example of a Gerber viewer that I use, and there are many others that you could search for online that you can try out. But the point of a Gerber viewer is for you to load up or import your generated Gerber files one by one, and you can see that they all line up. If your Gerbers don't line up on top of each other, then you have a problem. Maybe you did not set the you don't have the right numerical format, 2.4. Maybe you forgot to set the origin in the bottom left hand corner. There could be a variety of reasons, but let's just see what it looks like. So let's go ahead and click on here. Actually, I think it's like file import Gerber, so it's F2. Alright, so let's just hit F2. F2 import Gerbers, find your project folder. Nope. Let's go back. Documents. It's doing that thing again with where my my video capture application is interfering with me double clicking properly. OrCAD tutorial, Allegro, and so we want to start with the let's see, solder mask top. Let's change this by type. So solder mask top, import, and there's my solder mask, and then I select another layer. Then we want silkscreen top, import. Then I want copper top, import. Then I want my copper bottom, import. Then I want my silkscreen bottom. It should actually be solder mask bottom. Let's see if you want to put it in the right order, just to match what I have on the top. So let's do silkscreen bottom and solder mask top. I mean solder mask bottom. And lastly, we need the NC drill file. For that, we need to go on to File, Import. Let's see, drill and route, and we find the NC drill file, and then it adds the holes. Okay, and notice that the holes line up with my pads. If I disable this, see, I think the only information is in this layer here. So if I disable the drill file, notice that the holes line up with the pads. Okay, I clicked on the left mouse button to scroll, and then the middle mouse button to zoom in and out. Okay, so if I do visible, I can see that all of the holes will be drilled through the pads as they're supposed to, and they all line up perfectly. So I am positive that my Gerbers are good. Oh, we forgot to import the outline, board outline, and there's my board outline. And let's do, oh, that's interesting, there's nothing in the board outline. My board outline is empty. That means I need to go back and add an outline to my board. Okay, I will add that as an appendix to the video. So assuming that we have the board outline properly generated as well, we see that everything lines up. Okay, the solder mask usually should have some clearance. So if we take the solder mask, let's say we just look at the top layers and we disable all the bottom layers, and let's disable the silkscreen. Okay, and if I do solder mask and I do the negative, I can see that my solder mask is that green protective layer that covers everything except for where the pads should be exposed, so that I can actually solder or make electrical contact with the pad. But usually there should be some clearance between here and here. Your solder mask should not, and usually OrCAD should be able to do that automatically. Alright, let's go ahead. My eyes are hurting already. Let's put that back. Okay, board outline. Alright, let's take care of that, because that's important. So I'm gonna have to go back here. I'm gonna go to Color Dialog, and unfortunately I'm gonna have to turn everything off so that I can quickly view my my final. Actually, in fact, let me reopen. Let me save it, but let me reopen my final board that I had here for that specific purpose, so that I could start from a known place, and then I'm going to resave this on top of my original board so that I can go back to that. Okay, and once again, so to do the board outline, what we can do is basically we can draw a line on the board geometry subclass, actually on the board geometry outline layer. So I'm going to go ahead and add a line here. Oh, you know why? I wonder if because I did not put zero width line on my board outline. Let me try that experiment real quick. Let's go to artwork control form. Oh crap! I erased my. I shouldn't have done that. Okay. All right. Anyways, I need my only the board outline. So if I go back into my color dialog and I turn everything off, yes, and I just select board outline, apply. Okay, and then I go back here and I add a board outline. So I right click, add, and again I call it board outline. And I forgot to set undefined width for my board outline also. And I set it to 7, and then I click on board outline and I create artwork. Okay, and let's go back to my viewmate and let's see if we can go ahead and import. So import Gerber board outline. There it is. Okay. My solar mask is still inverted. There we go. Okay, that was the problem. I did not set a minimum width for my board outline here. Okay, as I did before when I had all the other layers. I made a huge mistake. I overwrote my original board that had also my selection of all my Gerber files, but that's okay. You got the idea, hopefully, on how to generate those files. And you need to make sure that for any layers that have graphical elements that are not related to the generation of the PCB, that are just mainly graphics, that you have that undefined. So mainly the silkscreen layers and the board outline layer, because this is just to illustrate where the board outline is, but it doesn't mean that it's actually a renderable graphic component. So we have to force it to render by setting an undefined line width of non-zero value. Okay, but that does generate all the files that I need. I can verify that for a fact. My board outline lines up with my board, with the holes. The holes line up with the pads line up, the traces, the top traces and bottom traces, they line up properly, etc., etc. Okay, so we are done. That's it. That's the how you construct the Gerber files and how you have your you generate those Gerber files in the NC drill file, and you ship those to your manufacturer, and you're good to go. Okay, guys, so that does it, and I hope that was helpful for you. And that's pretty much it. Thank you for your time.